Okay, I'm going to continue with some quadratic equation examples and problems today. So I believe we've already done some introduction in class. At a quadratic equation will be an equation that has an equal sign in it, and it will look in this form, such as ax squared plus bx plus c equals 0. That's a quadratic equation. 2x squared plus 5x plus 7 equals 0. That's a quadratic equation. X squared plus 9 equals, negative 18. That is a quadratic equation. X squared plus 2x equals 3. That is a quadratic equation. X minus 3 parenthesis x plus 3 equals 0. That is a quadratic equation because you have the capability of distributing and expanding this. So when you distribute the first term, this is going to be x squared, and that's what it depicts it to be, quadratic equation. You can have a solution or a question that looks like x times x plus 9. Is this a quadratic equation? Yes, all you have to do is try to expand it and see the first term is x squared. So yes, it is a quadratic equation. So now the next question is, how are we then going to solve these quadratic equations? So let's see and take a look at some examples. Suppose I have examples that looks like, let's say, some terms that has x squared and then equals with something. You need to make sure that these procedures are followed. The first thing you want to do is make sure that the right side of the, first of all, you want to make sure it's an equation, so that is an equal sign. Secondly, that the right side is equal 0. Then you want to make sure that the left side looks in this form, a bracket or parenthesis times b equals 0, and this is called a zero product rule. And then you want to make sure that you're able to set up such that a is equal 0 or b is equal 0, and you'll be able to solve for the variables. So if it is x, you're going to solve for x. If it is y, you're going to solve for y. So let's say we have these examples as you may have done in classes or even in our lecture. And suppose you have this question, x minus 3 parenthesis close parenthesis 2y plus 1 equals 0. So as long as you follow these three rules, you will not make a mistake in quadratic equations. So first of all, is the right side equals 0? Good, you pass the first step. Second step, you want to make sure that these two are in two product 0 or 0 product term. So does this look like a times b equals 0? Yes, it does. So you can set it up as step 3, that x minus 3 equals 0. Then you're going to write the word or you can put comma, it doesn't matter. The right side is 2y plus 1 equals 0. In this case, you have two different variables. So if you happen to see two different variables, is this quadratic? That's my question right here. So how do you know a function is quadratic? You will expand this. It is not x squared, so you do not continue. So be careful. Just because you can solve it, yes, I'm going to find x equals this, y equals this, but that's not the whole purpose of this course. This is quadratic. You want to make sure the power is squared. This is not x squared. I don't see square anywhere, so do not continue. So remember, this is just a trick to see first test pass, second test pass, and you want to solve for a variable, solve for x, but this is says x and y. So you do not want to continue. Okay. Let us continue with more examples. This time, no more tricks. So suppose it's x minus 3, then x plus 1 equals 0. So is this a quadratic equation? So by now you should be able to identify x times 2x is 2x squared. So yes, it's quadratic. So I can continue with all the 3 steps. Remember, the equations we're looking for is quadratic, and that's what we're trying to solve. So is the right side 0? Yes. Is the left side looking like a times b, like the zero product rule that we learned? Yes. So I can take the left side, which is x minus 3 equals 0, or 2x plus 1 equals 0. So when you do this, you want to solve it one by one. Solve for the first equation. X minus 3 equals 0 is an equation, so you can solve for x plus 3 on both sides, x equals 3. Then for the next one is 2x plus 1 equals 0. You subtract 1 on both sides, it will be negative 1. X is going to be, how do I get rid of 2? Divide 2 on both sides, it will be negative 1 over 2. So my solution set here is going to be written as 3 comma negative 1. So will I mark it wrong? I won't, but you want to make sure that you arrange in ascending or descending order, but usually is ascending order. So negative 2 comma 3 will be the solution. So it doesn't matter, but this is the right way of writing math. So because this is just an equation, it's not an application, you can just leave the solutions as is. All you have to do is plug whatever solutions you got one by one into the original equation. If you did get the left and the right is 0, you're done. But when it comes to application, you want to make sure that it makes sense. Is the solution make sense? Does the solution make sense? Can I have a length, or let's say I'm climbing a wall, a negative height? So you want to make sure, does it make sense? So let's see if we can take a look at an example, or say an actual application. So suppose that I have a ladder, and okay, this is an application that we can do. Suppose I have a ladder, or it doesn't matter, you have a ladder, and then you have a wall. So anytime you have these kinds of word problems, you want to make sure that you draw, right? That's what we have done in class as well. So we're going to draw a wall. So suppose I have a wall, and my question is, I'm going to put a ladder against the wall, which means I need to have a floor, right? I'm not going to do an hanging wall right here. So I'm going to have a floor. So I have a wall here, I have a floor right here, and I'm going to put the ladder and lean it against my wall. So what I can do is put my ladder up here and lean it against it. So let's say I want to draw on a different color, and that's my ladder. So my ladder is now right here. And suppose I'm giving you the length of my ladder, and I'm going to say my length of my ladder is 3 feet, and I don't know what's my floor, so I need to know the length of my floor. So if I say, what is the distance of the floor from between, so the distance between the ladder, right? Or I would say the foot of the ladder and the wall. In other words, this is basically the floor. So you need to understand, how do I translate this? What is the distance between the bottom of the ladder to the floor, the foot of the ladder to the floor, or to the wall? Sorry, not the floor. So that means it's the floor. So I can verify or identify this with a variable. I'm going to call my floor x. And suppose another, let's say, suppose I give you another description, and I will say, suppose that the top of the ladder to the bottom of the ladder, so we're going to say the top of the ladder to the bottom of the ladder of the wall is 3 feet more than the distance from the bottom of the ladder to the top. So what does that mean? That means top and bottom, the difference is 3 feet. So now let's say I'm giving you, this is given. So all this must be given. We haven't done any math yet. The distance from the top of the ladder to the bottom of the ladder, that means we're talking about the distance. So the distance from the top of my ladder. So let's write this first. To the bottom of my wall, well, apparently I own a wall right here, is 7 foot more than the distance from the bottom of the ladder to the wall. Alright, now let's translate it to English. Well, it is in English. Let's translate it to mathematics. So what would we do here? So first one, the distance of the top of the ladder to the bottom of the wall. Where would that be? The top of the ladder is where I'm putting a red circle, to the bottom of the wall, because that's my wall, right? That's my wall. The bottom is this. And they're saying is 7 feet more, which means this is plus 7 of something. More than who? Then the distance from the bottom of the ladder, which is, let me change to a different color. So let's say it's blue. Bottom of the ladder, so that's the bottom of the ladder to the wall. So bottom of the ladder to the wall, well, they are both overlapping. That is, I define at x. So when we go back, you say the top of the ladder is 7 feet more than this guy here. This guy is here is x, which means this is 7 foot more x plus 7. So I will write this as x plus 7 because this is x. 13 is already given. And I'm telling you my ladder is 13 feet is given. So now we're ready to do math. So the question is, find the distance of the bottom. So in the other words, it says find x. They won't tell you find x. The way they're going to tell you, find the distance between the bottom of the ladder and the wall. So they want you to find x. So what's the first thing you want to do? Sketch. Well, I've already sketched it for you. 2, you want to set up an equation. And you want to make sure you set it to 0 on the right side. Once you have set up the equation, you set up the right side equals 0. The third one, you want to make sure your equation has 0 product form, which means you can split it up as x times b, a times b equals 0. Then you're going to solve for a equals 0, b equals 0. So the first part, sketch, is done. Pretty colors up there. The setup, how do you set up this equation? So when you look at this is a right triangle, and anytime when you have a right triangle, so my triangle should have a right 90-degree angle, you want to think of theorem, Pythagorean theorem, right? So theorem Pythagoras says that if I have a right triangle, and if the bottom is A, the wall is B, the ladder is C, it's actually a squared plus b squared equals c squared. So you want to use this idea, but now you're going to use all the variables that I found up here in my diagram. So my left side will be x. Bottom is x squared plus, the height is the wall, x plus 7 squared. The right side is, you're lucky, there's no variable, is 13 squared. So what do you do next? Of course, we're still on step 2 because you're going to set it up nicely. Then you're going to factor it, right? So x squared plus, distribute x plus 7 squared. What would that be? This will become x squared plus 14x plus 49. So make sure you do the math and show me how you did it. Time equals, the right hand side is 169. So what is the next step? Of course, you want to find all the like terms, right? So x squared and x squared, you can combine them and that becomes 2x squared no more x, so it's just one x there. Remember, x squared and x are not the same. You want to keep them separate. 14x. Then you're going to have, the right side has to be 0, right? Subtract 169 on both sides. So that gives me negative 120 equals 0. Now set 2 is done. I want to set the right side equals 0. Yes. Now we'll go to step 3. Can I factor this? Before I factor this, notice every term here I have even numbers. So can I divide everything by 2? Yes, I can divide 2, 2, and 2. And that's going to give me x squared plus 7x minus 60 equals 0. And this is where the trick is. You all have to practice a lot on how to factor things out. So I'm going to end up with x minus 12, x minus 5. Is this true? I have 12 and 5, which gives me 60. But I want positive. So here I need negative, which means I can't have two negative numbers here. And 7 is positive, so 12 has to be positive. 12 minus 5 is positive. So be careful. So here the solution will be x equals negative 12. Remember, this is in the zero product form. A times b equals 0. Then I'll split them up as a equals 0, b equals 0. So I'm going to end up with two solutions here, which will be x equals negative 5, negative 12, x equals 5. But does this make sense to have this to be your solution? No, this is like no sense at all, right? It's an application. Does it work in real life? No. But x equals 5 works. So the question is, the floor to the bottom of the ladder, what's the length? The length is x, because we set it up in a way where this is the floor, bottom of the ladder. That's the bottom of your ladder, that's your floor. And this is the top of the ladder, and that was x plus 7. So what would the height be in this case? So if x is 5, height would have been positive 12. Is that right? So height is 12, and you're done. So this is how you do application in quadratic, any quadratic equation formulas and application. So let's take a look at some more examples that that looks pretty tricky, but you are trying to think, how am I supposed to solve it? It doesn't look like a times b equals 0, but actually it does. How can I identify it? This is how you do it. So let's take a look at a few more examples, and then I will go ahead and make other videos on linear equations and also how to solve inequalities. So let's say we have an example. EG stands for example. So what if I have negative 2p bracket p minus 1 equals 0. Remember, the three rules always apply whenever you're solving quadratic equations or any equation. Solve an equation means you want to make sure that the right side is always 0. And then if it is quadratic, you want to set up that your left side is a times b. Because it's quadratic, is to the power of 2, which means you have two items together. So that's what quadratic means. If it is a linear, you're only going to have 1. If it is quadratic, you're going to have 2. If it's cubic, you're going to have 3. But this is quadratic. So remember, we are studying quadratic right here. So it's going to be just two terms. And finally, you're going to set up a equals 0, comma, b equals 0, or a equals 0, or b equals 0. These are the only three steps you have, whether it's application or solving any simple quadratic formula. So, looking at this equation, does this look like? Step 1, is the right side equals 0? Yeah, it is. Step 2, can I put parenthesis around this, and does this look like a times b equals 0? Absolutely yes. Even though the left side is just one term, it's still an equation. I can still look at this as A, and the second one as B. Is actually A times B equals 0. Good. Now you can do step 3. A in this case is negative 2p equals 0, comma, or you use the word or, p minus 1 equals 0. And remember, anytime you solve any quadratic equation, you need to solve it one by one. So the left hand side, I can get rid of negative 2 by dividing both sides by negative 2. So p is going to be 0. And then on the right hand side, I can get rid of negative 1 by adding 1 on both sides. And that's going to give me p equals 1. So here this is not an application. So you don't care really, I would say, as long when you plug the solutions back into the original equation, on the left hand side equals right hand side, that's it. It has to be correct, right? So the solution set, the way you're going to write it, you start with the smaller number, so it's going to be 0, 1. So that's how we take care of examples like this. Let's take a look at another example. Every time you want to make sure, does this look like an equation? Can I make it into a quadratic equation? What if I have w times w squared, let's say, minus 5w plus 6 equals 0. So remember, you have to be able to break it up in product, zero product rule. It doesn't matter if I have 2 or 3. In this case, this is not quadratic, but do you have a quadratic in it? Yes, which means this is something you can split up. So the first term, do not distribute it. Keep it in the front. And this 2 can be split up. And this will look like w minus 3, w minus 2 equals 0. This is still a product rule, but what's happening here, you're having 3 terms. So it doesn't matter, as I told you earlier, if it's cubic, it's going to be 3. Even though this is a quadratic topic, you do have quadratic in this. You just want to know, how do I set it up as zero product rule? So I can set a equals 0. So in this case, this will be a equals 0, b equals 0, c equals 0, and you solve for all the variables. So here my a is w. W itself is 0. It's already solved. So you're done. Or second one is w minus 3 equals 0. So w is 3. Or a third one is w minus 2 equals 0. So w is 2. And you're done. So your solution set in this case is going to be 0, 2, 3 in ascending orders, and you're done. So in this case, you have 3. So when you have 3 solutions, you know it's not quadratic. It is cubic. But I just wanted you to have some exposure. Does it matter if I gave you something, an equation that's already factored? Doesn't matter as long one of it is quadratic, because we are in quadratic question. What if you have a question that looks like x squared minus 16 equals 0? Is this quadratic? Yes. Does that mean I'm going to have a zero product rule? Yes. But before that, you need to make sure that the right hand side is 0. Is the right side 0? Yes, you passed it. Can I factor the left hand side? Because right hand side 0, I'm going to leave it. X squared minus 16. Do you recall how that is done? You want to remember, we did that in class before. If I have a factor a squared minus b squared, I can split it up as a plus b, a minus b. And that's the idea we want to use here. So before I factor it out, let's recognize this. Does this look like x squared minus something squared? Yes, this looks like x squared minus 4 squared equals 0. So I can set this up. That's another way to solve this problem, absolutely. But this is one of the way we want to learn. So this is method 1. And I can break this up. This is x plus 4, x minus 4 equals 0. Does this look like a product? A times b equals 0? Yes, so I can set it up as x plus 4 equals 0 or x minus 4 equals 0. So x is going to be negative 4 because I subtract 4 on both sides. I can write comma instead of 4. X is going to be positive 4 because I plus 4 on both sides. So my solution set here is going to be negative is smaller, so negative comes first, so negative 4 comma 4. Is there another method for me to solve this problem? Yes, for some of you, if you're already expert or you are more familiar with how to do this in the past, you know you can solve x squared minus 16 equals 0. You can actually write as x squared equals 16. You plus 16 on both sides and you're going to end up as, so let's do it here. Let's continue it here. So this is going to be x equals, to get rid of square root, you want to do square root on both sides. But when you're doing this, you have to be careful. Square root will be plus minus, which means your x is going to give me two values. Square root of 16 is, what is square root of 16? Is 4. But I'm going to have two values. I'm going to have plus 4 and I'm also comma negative, right? Negative 4. So if you're going to use this method and you want to square root it, my suggestion would be you should know how to make sure to show the work that it is positive and negative. Otherwise, this is the actual method of how to solve a problem in any exams in an algebra class. So you want to make sure you know how to do it. All right, let's just do like maybe 2 more questions on this, so you should be more familiar with how to solve any quadratic equation. So let's say I give you something. What happens if it has a fraction? So suppose I have 5 over, let's see, 5 over 4, and I'm going to change my variable. So in this case, instead of x, let's do v or w squared minus 1/4 equals w. So they're all w and no parenthesis anywhere. Is this a quadratic? Yes, which means you're going to have 2 solutions. And remember, you always have 3 steps. The first step is make sure right hand side is set up to 0. Put all the like terms together, get rid of fractions and anything. It has to be in one line. Number 2, you want to factor it out in a way that it looks like a times b equals 0. So I can just, I'm not going to say a or b, but it's just to give you an idea how would it look like. And number 3, you want to make sure that you are able to say a equals 0 or b equals 0, and then you solve it. So here, what do you do? The first step is right side has to be 0, so this will be 5. These are some of the examples that you did in your activity, okay? 5 over 4 w squared minus 1 over 4. What's the next step? Minus w, very good, equals 0. So if you subtract, while I'm making a video, I'm assuming that you're answering these questions with me. Now I want everything in one line. I don't want fractions. So you want to get rid of fractions. You will multiply every term. Remember earlier we did when there's an even number, you divide every term by 2. Here you multiply every term by 4. So what happens if I multiply the first term by 4? 4 and 4 gets cancelled. The second term by 4. 4 and 4 gets cancelled. Fourth term by 4. Nothing to cancel for the fourth term. So first term will become 5w squared minus 4 and 4 cancel, so it's 1 minus 4 times w is 4w equals 0. But remember, what's the standard notation of any quadratic equation is ax squared plus bx plus c equals 0. So which means x squared comes first, followed by x, followed by a constant. But here w is at the end, so let's rewrite it. 5w squared minus 4w minus 1 equals 0. So let's solve it up here. So here you can do several options. If you are very confident on how to do the cross method, box method, go for it. But your first coefficient is not pretty. It is, it has x. So I can write it as 5w squared minus 5w plus w minus 1. Why did I do this? I'm actually doing grouping. Remember, we studied this grouping in the past. Negative 5 plus 4 is plus 1 is negative 4w. So that is what I'm doing this for, so that I can easily group things. Alright, so this one I've already grouped. Now what I can do is I can rewrite this as, how can I rewrite this as? I can rewrite this as, oh, don't forget your right hand side is equals 0. This looks like 5w squared minus 5w plus, put parenthesis here, 5 minus w minus 1 equals 0. Now can you see what's happening here? I can't factor out 5w. I'm left with w minus 1. Then this side, there's nothing outside here, which means it's 1 w minus 1. Now if you remember in the last exam, how would you do this? You group things together. These two can come out, w minus 1. Factored out, what's left? You're left with 5w plus 1. So don't forget your plus. Plus 1 equals 0. Now does this look like your step 2? Yes. Then you can set it up as w minus 1 equals 0 or 5w plus 1 equals 1. So on left hand side, w equals 1. The right hand side is you have a little bit more work to do. 5w equals, it should be equals 0, negative 1, because I subtracted 1 on both sides, and w is negative 1 over 5. So what's your solution set? Remember, your negative number is smaller than positive, so negative 1 over 5 over 1. So this was negative 1 divided 5 on both sides, so it's negative 1 over 5, and you're done. These are the solution set for this quadratic equation. So if you need more examples, let me know, or just leave a comment or message and I'll be able to add a little bit more example, probably with some I would say applications. All right, thank you, and I will see you in another lecture.